Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is isomorphic strings. So the problem statement goes like this: given two strings s and t, you have to determine if they are isomorphic. Okay, what is the condition for two strings to be isomorphic? Two strings are considered isomorphic if the characters in S can be replaced to get T. Okay, so all occurrences of a character must be replaced with another character while preserving the order of the characters. Okay, no two characters may map to the same character, but a character may map to itself. Okay, so let's try to understand here what are the things that we have to check for to check whether these strings are isomorphic or not. Okay, so first of all, what we can let's take an example and try to understand by that. Let's take the very first that is given to us. And before going with the examples, let's have a look at the constraints. Okay, so the length of the string s is of order 5 into 10 raised to power 4, and both string s and t will be having equal length, and it is told that s and t consist of any valid ASCII character. Okay, any valid ASCII character that can be there. Okay, so let's see how we can approach this by taking first example and trying to understand what conditions we are required to check. Okay, so as you can see in this particular one, what the problem statement is saying is all the occurrences of character must be replaced with another character while preserving the order. Okay, so first of all, two things are really important here. First one is that the order should be preserved. Okay, order of characters, and if you are replacing E with, let's say, a character X, then all the occurrences of E should be replaced by that character only. For example, here G was replaced by D, so all occurrences of G should be replaced, not the single one. Therefore this one also should be replaced. Okay, so and E should be replaced by A. As you can see just from observing, after replacement S will look something like this. Okay, so which is by the way equivalent to T. That's why we should be returning true. Okay, so then no two characters may map to the same character, but a character may map to itself. Okay, this is the very crucial point that is to be noted. What the problem statement is saying is, let's say these were the characters in first string, or let's say S, and these were the characters in T, A, D and D. Okay, so the mapping should be like this. Okay, or let's do not take duplicate characters, let's take only unique characters. Okay, so as you can see, there is one-to-one mapping only. By one-to-one means every character from this side is mapping to only single character on this side. There should not be case like this. What kind of case like this? Okay, so E is also mapping to A and G is also mapping to A. So this kind of thing should not exist. Otherwise you should be returning false if that is the case. Okay, so that is what here that is what mentioned here. No two characters may map to a same character. So you can see that two different characters of S are mapping to the same character of T. Okay, so this should be not there. Otherwise, if you do the replacement, then it will result in A, or it you can see for yourself that it will result in ambiguity. If you were to map T back to S, or somehow convert T to S, then you would be in an ambiguous kind of situation. I mean, if you are trying to convert A, then it can be converted in two things. Either it can be converted in E, or it can be converted in G also. So this kind of ambiguity should not be there. Therefore the mapping should always be 1 to 1. Okay, not many to 1. Okay, and it is entirely possible that, let's say, there were any other character, let's say F, and after that D, there will also be an F. So it is possible that the character is mapping to itself. Okay, so this is no case to worry. The only concern was that mapping should only be 1 to 1. So these are the conditions that we have to check actually, and on top of that, other thing that we have to check is, first one is that we have to check is mapping. Okay, and ordering of characters, I would say that will be automatically checked by the approach that we will be discussing. We are only concerned with the mapping, and other than that we are also concerned with the frequency. Okay, so it should not be the case that let's say this double G instead of double G, this is S is this string, okay, EG, and T is ADD. Okay, now although the 1-to-1 mapping criteria is being fulfilled, but you can see that if you take all the replace all the characters of S, even then you would not be able to form a string which is equivalent to T. Okay, so that's why frequency also matters here. How so? This twice occurrence of D should be there in S. So we should somehow be able to compare the frequencies also, after replacement or before replacement, that is entirely our choice. So we should be having some comparison of frequencies also. Other than that, these are the two things that we will be checking for, and once these two things satisfies, then we can for sure say that okay, it's everything looks fine, and these two strings should be isomorphic. Okay, these two conditions should be checked. So how we will be checking these two conditions? For that, let me take you to the implementation part. There you will be able to relate in a proper way, as compared to me being just explaining you the approach. Or I would, okay, let's take some portion of the code here from here, and then we will discuss. Okay, this is the code that we'll be using. First of all, we are using an array of size 256. So we were mentioned in the constraints that S and T can consist of any valid ASCII character. So from experience, I am saying that 256 is sufficient enough to take any ASCII character as your input. I mean, internally these ASCII characters are stored as integers only. int values. So that's why 256 is sufficient, and an array of 256 size would be sufficient to, you know, map all the characters. So instead of using a map, we are just using constant space of 256. Okay, so these two things are there. What these two arrays do, t map, char map and s char map, they are nothing but essentially these two sets. Okay, so there is an array of 256 characters for both s and t. Okay, so first one you can say this s char map, and second one is this t char map. So what we are doing here is we are traversing the both of the strings only once here in this particular loop. Okay, so single traversal is being done here. Linear traversal you can say, actually they will be traversing more than once, so linear traversal. So while traversing the strings, we are seeing what are the characters in both. Since length of both of strings are mentioned to be equal in the constraints, you can see the second constraint that both will be having the equal length. So that's why we will always be having at least one characters in both of these while we are traversing. So we will try to, you know, take those characters and you know, find the corresponding indices in these two arrays. So t index and s index. Okay, so their ASCII values will be indices here. Okay, 0 to 256, and it is also from 0 to 256. So ASCII values taken as indices. Okay, so if we are you know, considering the t index that is being generated from the character that we are you know, at in the t string, you know, so corresponding to that we will be entering our character at s string. Okay, so what we are doing here is let me take to one slide back. So we are just mapping you know, this, we are doing this mapping. T a is mapped to e. Okay, so we are taking a's ASCII value as index in t character map, and at that particular index we are inserting ASCII value of e. Okay, so it will look something like this. If let's say I don't know what is the exact value of ASCII for a, but let's say it's 0, then at the very first, you know, at the very first index or the 0th index in this t char map, we will be putting the ASCII value of e. Okay, so ASCII of e, which is, by the way, character from, you know, s. This one is character from s. Okay, so this is what we are doing. We are just forming these two mappings. Okay, and checking whether there are any, you know, one to many mappings or not, and if that's not the case, then we are just fine. Okay, so this is what we are doing. Initially we are, you know, inserting both of these arrays with -1s, indicating that we haven't seen this character before. Okay, and if at any case we haven't seen this the character before, I mean this mapping has been not been formed. So currently we are forming mapping from T to S. Okay, and here we are doing the same thing for S. This is for T. Okay, this whole thing till here, and this thing below thing is for mapping from S to T. Okay, so if the character is not seen, then you will simply put do the mapping. Okay, here we are doing the mapping. So we are just connecting this A with E. Okay, this is the mapping that we are doing in this step. Okay, this particular step. So once this is done, then if that's not the case, that this mapping already exists, then we will check whether there is many to one mapping or not. Many to one mapping. Okay, it means that this character, you know, is already mapped with some other character, and right now we are again mapping it with some other character. Okay, what is the condition here? So something like this is happening. This is, let's say, S and this is T. So let's say this is E and this is A. Okay, so E is already mapped to A. Okay, but after some time you are saying that E is now being mapped to D. So you see that there is a many to one mapping existing here. Okay, so if that's the case, then you will be returning false for sure, because we were mentioned in the problem statement. Let me zoom it a little bit. That no two characters may map to the same character, but a character may map to itself. Okay, so you can see that A and D are mapping to E only, so that's why this is many to one mapping, and this kind of things should not exist. Mapping should be one to one, so we are checking that here only. Okay, and we are just repeating the same thing for S. This is we are doing for S. We are just doing the reverse thing here. Okay, so from A we are doing this mapping to E. Okay, so if you know, there are no anomalies here after you know, traversing this complete loop, after you know, going through this complete loop, then we are fine, and we have to just check for the frequency part. For frequency part, what I have done is, I have taken a frequency map of 256 size, which is obvious because it was mentioned that any ASCII character could be there. Okay, and corresponding to, I am taking characters as frequencies, characters ASCII values as frequencies. Okay, character ASCII values as indices, not frequencies, pardon please. And then corresponding to those indices, I am just increasing the values. I mean, it will be initialized with 0, so I am just increasing the frequencies. This is we are doing for after traversing S. So S frequencies being counted here. Okay, then what we will do, then we will simply decrement the frequencies of the characters present in T in the same array, and if at any instance the frequencies drops below 0, okay, so it means that, you know, that character is being present in T more than it is present in S. Okay, so that's why we will be returning false from there. Okay, So, and you may ask that how I am taking care of this mapping thing. I mean, in this add and egg, D was being mapped to G. So I should be, when I am, let's say this is S, okay, and its frequencies are stored in this particular array, which is, by the way, this frequency map. So if this frequency map is having frequencies of S, now how would I relate these frequencies of these characters to these ones? For that I will be using this T character map. Okay, this T character map will come in handy here. Okay, for T character, from T character map I would be knowing that this E character is mapped to which character of S. Okay, so I would be in an instant able to know that okay, this E is mapped to A, so I should be decrementing the frequency of A. So that's why I am taking I am doing this step here. Okay, so now that out of our way, we are just comparing the frequencies, and if there is no anomaly, and the frequency part, this is the frequency part. Let me change color little bit. So this is frequency part, frequency check, you can say. Frequency check is also okay, and mapping check, one-to-one mapping should be only allowed. Okay, this is also checked. So if both of these are passing, then we can see that okay, these two strings are isomorphic. Okay, so that is how we are approaching the whole thing. And if you want to see implementation in a little bit more clearer way, let me zoom out a little bit, and this is the implementation. Okay, so we are just taking two maps to, first of all we are using these maps for mapping check. Okay, and initially we are filling all these maps with -1. This is the whole procedure I am being repeated here, the one that I have just explained to you. Okay, and then we are also having a frequency array that will initially be storing the frequencies of characters in S. Then we are checking for if there are any many-to-one mappings present, then in that case we will be returning false. We are checking for both S characters mapped to T and T characters mapped to S. Okay, both of the case we are checking. So this one is for, you can say, T's character mapped to S. S is character. Okay, S character. Okay, arrow is going from T to S, and here we are doing for S character mapped to T's character. Okay, so when these two checks are passing, I mean there is nothing wrong here in the whole thing, then we will be doing the frequency check. This is the frequency check. Okay, and yeah, if the frequency check is also passing, then we are good to go, and we will be returning true. Okay, and this is a crucial thing that we are using T's character map, this mapping T's character map to S, to get the index that we have to decrement for checking the frequencies. Okay, so this is how we will be solving this particular problem. And as far as time and space complexities are concerned, you can see that we are just doing linear traversals here, so your whole time complexity should be order of let's say S is of size len, or you can take size also. So order of size, since S and T will be in equal length, and space complexity wise we are using 3 arrays of 256 size, so you can either take them as constant, or you can, if you are considering them, then it is 3 into 256. Okay, it is order of 3 into 256. Okay, so, and this fill function is by the way of linear time complexity. We are just filling the indices. So this is the approach, and these are the complexities. If you still have any doubts or any queries in general, then you may ask them in the comment section. Thank you for watching. Have a great day ahead.